This is the LG 415 course project video. It will be a step through of the entire project from beginning to end and demonstrate how to use Excel to create the charts, reformat the axes and to answer the questions and provide analyses of the data that you will be examining. The course project file is very simple. This is your scenario that you're going to be doing. You're going to be doing all of these functions down here. One of the biggest things that I have to address is accuracy and following directions. You must follow all the directions to the letter, and these are the point distributions for all of the outputs that you will be doing. These are exact, and you must comply with all of the requirements for this project or points will be deducted. It's just that simple. Things have got to be done in such a fashion as this project video is show you exactly how to do it. It takes about probably about an hour to 2 hours to get done from start to finish. So you can start working on it, save it, and then come back and finish it up. The hardest part will be the analyses. Everything else that is in here is very simple to do. Okay, and most of it, I apologize for that. Uh, Most of this is stuff you've already been doing or have done in the course. So let's go over the actual scenario here. Basically, you're going to be making widgets, okay, and you produce specialized widgets for a customer, which would be me, that requires tight specification limits. The widgets are to be 5.5 nominal. Okay, that is what your target is. I want them 5.5 inches long, plus or minus a half an inch. So the total spec limit is going to be between 5 to 6 inches. As plus or minus is 50% from the nominal. Okay, what we've done is we're going to set up a production line to produce a test run before we start actual production run. The test run is going to be the data set, first data set, and that's going to tell you, do I need to make improvements on it to bring the production down into the customer parameters, and what do I have to do about that? Okay, so we're going to have 20 sample sizes per run and 4 runs, and that's 80 samples altogether. Okay, because of the specification and the setup, what we're doing is a systematic random sampling. In other words, what we're doing is we're going to start at the same point on each of the different days, the 4 different days when we do our runs, our production runs. We're going to pull 20 samples basically at the same time every time we do the run. Okay, so this way we have comparative data and we're not looking at apples and oranges, we're looking at apples to apples. So the first sample is going to be taken at a specific time every single day. That way we can compare across the daily runs. Okay, so we want to make sure we understand that. Okay, there is another document here about the additional type stuff, which I have provided some of the formulas that you're going to be using. This is just basically restating the project course file, which we've already looked at, and we're going to be using line charts and IM charts, individual measurement charts, what these are called. We're going to be stacking data and doing all kinds of things. Okay, now all you have to do is complete the completed spreadsheet in the project Dropbox of the course. Okay, everything in here, and here is the actual file. This is the data set run. Every one of these file boxes are big enough to where you can put in a very detailed analyses. Now we'll show you how to expand these out if you need to get your analyses all in here. But we have to make sure that we have enough data, the correct data plotted up here, and to make sure that we have the analyses that describes every one of these functions that we're looking for. So each data set is going to have the same number of outputs for the charts and for the analyses. Okay, those have to be done. Okay, basically what you're going to do in data set 1, you're going to repeat in data set 2, which is the exact same thing, except the only thing that's different are the numbers here. Okay, so let's start with the data. First thing what we want to do is we want to get these averages. So this is what we call the X bar chart. We're not going to do the range chart, which is usually accompanying the X bar, because just for time considerations, and you can still do the analyses just for the X bar. Okay, but the first thing we need to do is get these averages for all these subgroups. So here's the data for the first run of 20 for day number 1, day number 2, the data set for the second run of 20, same thing for 3 and 4. Okay, so these are on successive days. All of these are taken approximately the same time across the days, and we're going to compare across the days. Okay, we're not going to compare down, because that's really not going to tell us much how we're operating from day to day. And that's what we're trying to find out. Can we consistently produce the runs on a daily basis? So to start with, let's go back to our Word document. This is to the additional project information, and right here is the formula that you're going to be using for these data right here. Okay. So the best way to do this, since we're just going to be copying this stuff in, is just go over here to our document, highlight this right here. You can try to get the parentheses. If you can't, don't worry. You can always type it in later. Right click, obviously, copy it, and go back to your document. Go up here into the toolbar, and you have to type in equals. I forgot to grab the equals from the formula. Sorry about that. And then Control C to put the formula in, then close the parenthesis and hit the green check mark or hit enter. That automatically gives you your average. Now to copy this down, you just go up here, put your crosshairs on the black box in the lower right hand corner, left click, hold it down, and just drag it straight down. That automatically gives you your average. And notice that all the calculations are already automatically done for you. Okay, so it gives you your standard deviation, it gives you your grand mean, which is just the average of the averages. So the average of all these numbers is 601. That tells you where the grand average of our data is. Okay, and then what we're going to do is we're going to, the chart will automatically populate. Okay, in fact, I believe that I've got the wrong file here, because I've got the chart parameters for the axes in the correct document. So let me pause this and let me open up the formula, the one with the file with the correct file stuff in it. Okay, I've got everything corrected now, so we can go. I'll just redo what I just did before. I'll highlight this formula, copy. If you notice, this is what the charts are going to be for you. Okay, the chart's automatically going to populate, so there's really not a whole lot you have to worry about that, and I'll show you here in a second how that works. So we're going to go up here to the formula bar. We're going to copy in our formula, and we're going to highlight this all the way down. Now the grand mean is the average of the averages. Okay, what I showed you before, I already had that in there. So the grand mean, all we got to do is just grab this formula, go back to our data, put that in here. Actually, go up to our formula bar, paste it in there, and it's going to average all of these up. We're still going to get the same values as you saw before, but I'm just showing you how to copy from the file into it. And then the standard deviation is right here. Again, we want to click the cell, go to our text bar, and everything else populates. Now what we're going to do is we're going to chart all of these data. Okay, so we're going to highlight all of this, then we're going to go to insert line chart. We're going to grab this first one. Do not use this one. Okay, this is really distracting. If you populate it, you can change it, but just don't use this, because the dots kind of, with all the data we have, kind of makes things a little messy. So make sure we just grab the 2D line, okay, and there we have our chart automatically calculated. Now we've got to format our axes. Okay, so what we're going to do is left click on the numbers here. They will highlight, then right click, do format axis, and here are our values. 6.8 is the maximum, 4.8 is the minimum, excuse me. So our minimum and maximum are going to be fixed, and the major unit is going to be fixed. So we're going to put the minimum at 4.8, the maximum at 6.8, and then the major unit of 0.2. Click close, and there's our data as it should be presented. Okay, now what we're going to do is just drag this over into our box and then expand it out. And like I said, the analyses should be typed in here. All we got to do is just click in here, and you'll see that this pops up here. All we got to do is just highlight that, delete it, and then we can just start typing. Okay, now to get this to where it's supposed to be, what we're going to do is we're going to go to our home, and we're going to click top of line, and we're going to click over here. Okay, now to add as you're typing it in there, it's just going to be a regular word processing. When you hit enter, it's automatically going to put your text in there. So if we want to add a line, we're going to hit alt and then enter. That means you can add a line. Now if you go up here, you can expand out the formula. You can see that we have an added. So to add a line, use alt, sorry about that, alt enter. That adds a line. Okay, so alt enter automatically does it. So you can type in here all kinds of stuff. Okay, and you can fill this box up with your analyses, and we're going to talk about that here in a second, but you can do these for all the text boxes. Okay, if you run out of room, what you'll do is you'll highlight the box and just draw it down however many rows you need. Okay, then you'll right click, format cells, you're going to do alignment, going to click the wrap text of the merge cells, then you're going to do the border, and you're going to click this line and then the outside, and it automatically wraps it around, and then it automatically expands it for you. That's the same thing with all of these text boxes, and I'll show you how to move all this down here in a second. So let's take a look at the data. Now what you're going to have to do is when you're looking at these data, you're going to have to remember that in your Word document here, the parameters are 5.5 inches plus or minus a half, or 5 to 6 inches. Okay, so what you have to do is you have to look at this. Right now we know that our parameter, our mean, is already at 601, which is above the 5.5 that our specification requires. Okay, so that's going to be the first thing you're going to be talking about. Then we're going to talk about these trends that are right here. We're seeing this is very erratic, and I want to see that. I want to see you tell me that's an erratic pattern that undulates above and below. Our process limits, our natural process limits, are well above the stated parameters of the customer. Remember, it was 5.5 plus or minus 1/2, which is 5 inches to 6 inches. We're already at almost 7 here, and we're over almost 5 1/3, 5.3 inches instead of 5 here. So we're well above our stated parameters. Okay, so 5 is right down here. Remember, if I were to draw a line here, just to show you, whoops, sorry about that, I want to do shapes. If I were to draw a line at our customer requirement, that would be here at 5. I'm going to blow this thing up kind of big, that way you can see it. And our maximum, or our our minimum, excuse me, our nominal is going to be 5.5, which would be right there, and 6 is our maximum. So there is our, whoop, that should be down here. So there's our parameters of the customer, and this is where we're sitting, right here at the LCL, the grand mean, and the upper control. So we're already well above where our customer specifications have told us that we want it to be. All right, that has got to be in your analyses. We're already above it. Plus we got the undulating parameters here, and then we have a big spike, then a drop off, then another spike. So we have some real serious problems going on here. We can't maintain any kind of consistency, and then all of a sudden we start dropping down. Now that's kind of weird, because why would we start dropping down in our process if it was supposed to be consistent? This is a big drop off. So something's going on here that we could assume is a special cause variation. Well, most of this is special cause variation, even though our natural process limits tell us that it's within those natural limits. So this is the max we can do right now based on the process as it stands. But we have some very serious issues here. Okay, so we want to make sure that we identify the fact that we're not meeting the customer requirements based on our natural process requirements. Our standard deviation is very large, okay, which means that we have a wide disparity between the grand mean and the individual values that follow a normal curve. Okay, the biggest issues that we have here is that so undulating. We have two serious dips in our data, especially towards the end. So basically the process is getting better as it goes along, which makes no sense. Okay, why are we getting better? What's going on here to account for this dramatic downward turn in our grand average? Okay, so starting right here at 0.19, we drop from 612 to 540. What the heck happened between those two? We don't know. So we can speculate, but we really don't know until we get in there and do some process improvements, and that ought to be in your analyses here. Okay, now what we're going to do is we're going to do these two over here, the IM chart against the process mean and against the specification mean. Okay, now let's start with real quick. We're just going to stack the data, and all we're going to do is we're going to highlight this column, Control C, go over here, Control V, and we're going to do the exact same thing with all of the data. We're going to stack the data. Okay, and what this is going to do, this is going to, sorry about that, hit the wrong button. And what this is going to allow us to do is plot the data in an IM level from start to finish, from the very first one to the very last one. Okay, regardless of the day, these are the order in which the data was collected. So we're going to stack it. Okay, first thing we're going to do is we're going to do descriptive statistics on it. Okay, so we're going to highlight this all the way down. Then we're going to go to our data tab, data analysis tool pack, do descriptive statistics, click OK. And the range, the only reason I do this is just to let me know that I've already highlighted it, but I have to highlight it again just to make sure you get the descriptive statistics. Okay, all the way down. Click that box right there. We don't have the labels, and in fact we need to probably grab that. So let's grab the whole entire column. Okay, I apologize for that again. Labels in the first row, summary statistics. None of this stuff is necessary. We just want the summary stats. Click OK. Here's our descriptive. Okay, now we have to look and you have to pay attention to this because this is very important. If you notice, the mean has got to be right there. The standard deviation has got to be right there. So what we have to do, dadgummit, I'm sorry about that, is go over here. We're going to grab these data, right click, copy, and we're going to go back to our data set 1, click right there because there's the mean and there's the standard deviation, then Control V. Notice that everything populates in here. Okay, it's okay to leave this here, but what we like to do is we like to kind of clean things up. So we're going to put these down to about 2, decimal places. So we're going to highlight these cells, right click, format, going to go to number, decimal places is 2, click OK, and then we're going to do this all the way down. Okay, so we're going to highlight all that, then hit Control Y. Control Y just means repeat the last thing I did. Okay, so there you have it. Standard deviation is right where it's supposed to be, and that helps calculate these values over here. Okay, the mean is here, obviously helps calculate the mean here. Now what we're going to do for this chart is do the same thing as we did over here. We're going to grab the stack, process mean, UCL, and LCL, come all the way down, grab all the 4 columns, insert, line chart, remember the 2D, and there it is. Okay, now we're going to move this up so we can look at our parameters here. 8 and 4, major unit of 5, of 0.5 I should say. So again, we're going to click here, left click, then right click, format axis. Max, min, and major unit are all going to be fixed. Minimum is 4.0. Max is 8.0. And the major axis is 0.5. Now the reason we're doing this is to display the data a lot better than what was in there. Before we had that real tight and we couldn't tell anything. Here we can tell a lot about what's going on. So now we can move this up, fit it into our block, and there's our data. Okay, now the analysis has done the same thing as over here, but let's take a look at the analyses here. We can tell that again this represents what we have over here, but it's an individual form. Remember, these data are XBAR, which means we're taking the averages of sample sizes. Okay, we're going to group these into groups of 4, and so now we can tell the runs over a period of time, okay, against the days. Here we can see the individual. Okay, so we can see that again, here's our big drop off between 625 to 509, actually from 637 to 505, and we can actually put our data point there. So there's stack point number 78 and stack point number 77. So 637, and then we just continually drop down, which basically corresponds to what we have over here, because remember, these are all averages of these 4 data points right here. Okay, so again, we have an erratic pattern. We're well above our stated process mean, or excuse me, of our spec mean. That's coming down here, but the process mean, it's in control with our natural process limits. Okay, it's in control, so I want to see that in your analyses. But the pattern is very erratic. We have so many undulating points here. It's not out of control because it's within our process spec limits, our natural process spec limits. Make sure that's put in here. Okay, our natural process limits. It's in control, but it's very erratic, and it's above the customer stated specifications. So what other customer specifications? So the spec mean is 5.50. The upper spec is 6.00 and the lower spec is 500. That's straight off the document right here, straight off this document. Okay, 5.5 plus or minus half, 5 and 6. So we just copy that over to here. We're going to highlight that, Control C, and all we're going to do is highlight all this right here, then Control V, and then we're going to take the stack data and copy it over into the other stack column. This is exactly the same processes that you're going to do with data set 2, the exact same steps. Okay, the only thing different is these axes over here. You have to remember to format the axes to the stated units. Okay, so now we're going to do the same thing with our charting. Okay, highlight all this, insert, line, 2D, there it is, and then we're going to reformat our axes. So left click, right click, format, going to fix here, minimum of 4.8, maximum of 7.2, and the major unit of 0.2. Close. There you have it. Now what we're doing is we've just taken our process and we plotted it against the specification. Okay? And of course it's giving me a hard time already, so there we go. First things first, we are well above and we are not meeting the customer specification, because that's what these lines are. Those are our customer specs, and look at how far above we are. Here you're going to have to tell me how many are above our specification limit, are out of control. Okay, we have some down here that are touching the bottom control, which is fine as long as it doesn't go beyond that or go below it. We're still good. Now, how do I know how many are out of control? It's very simple. What I can do is I've already got this column highlighted. It's already checked. I can move over here to the right, find another column, Control V. Well, yeah, because I want to go up here. I don't have the stack, so I just have the numbers. So Control V, and then what I want to do is go to Data, Sort that column A to B, smallest to largest. Okay, notice that we haven't quite touched the 5, the lower limit. Okay, so we're above it, so we're still good there. Okay, we're not going beyond or making bolts too short, but we're making bolts too long, or widgets too long, I should say. And because our spec limit starts at 6, from here down is all the ones we just produced that were out of specification by the customer. That's 39. Okay, you can't put that in there as 40, but 39 is the exact number. The only reason we would look at this as being out of control is 6 is right on the edge. I mean, that's barely meeting the spec. It's still within the customer specification, but we would like to make sure that we don't hit that. Okay, I'm going to pause for just a second. Okay, just to make sure, the solution that I've created includes a 6.0 as part of the non-compliance, so that would be a grand total of 40 that are out of control, because that is right on the top part. So we don't want that, and we want to be below that. So we want to make sure that we include this value as saying that there are 40 widgets that we're producing that are not in compliance. That's over half. So that's 50% of the widgets we produced in our trial run do not meet the customer specification. That's also going to be down here. So we want to make sure we mention the erratic pattern. We want to make sure and say it's not in control, and say it's not meeting customer specs, and 40 out of 80, or 50% of the widgets that we produced in the trial run did not meet customer specifications. Okay, which means we got to do a lot of work to get this within customer specs. Okay, so here are our section data set 1 questions. Customer spec for the widget mean and the widgets, that's coming right off this document. The 5.5 plus or minus 5, so it's 5 and 6 and 5.5. So the customer specification for the mean is 5.5. Upper is 6, lower is 5, so that's 5.5, 6.00, and 5.00. Now the X bar, grand mean calculated UCL, okay, is coming right off of here. The grand mean is 601, UCL and LCL are right there. Let me shorten this back up. Okay, so right there are the answers for this question right here. Grand mean is 601, calculated UCL is 673, and the LCL is 529. Those values go in here. Is there an issue with the group data? And that's a big yes. What's the issue? And this would just be a very short synopsis of your analysis here. Okay, very short. It doesn't have to be very lengthy to say it doesn't meet customer spec. In fact, I'm just going to close these out so that way I don't continue to go back and forth here. Okay. Make sure in the data set 1 that this is just a very short condensed version of what your analysis here, which should be lengthy and detailed. Okay. Then we go to the IM. What is the calculated of the IM? Okay, now the individual is right here, okay, is 601, 72, and 3. This is the spec mean. This is what we have our natural process limit. This is the ones we want to grab. Okay, so those values go in here. Is there an issue? Yes. Okay. How many widgets are out of specification? That would be 40. Okay, what's the issue? Again, this would be a very small synopsis of what's in here, of what you do. Okay, like I say, it has to be detailed and you have to be very specific about what's going on here. Okay, I just kind of alluded to the variation, to the erratic pattern and the variation that's being done, but we're in control based on the process limits, but we're not meeting customer limits. Down here, same thing. It's just this data plotted against the spec mean, which means we've got problems. Okay, so and you have to be very detailed about that, and you have to be verbose. In other words, use verbiage. Try to stay within the box. Don't over expand on it. Just make it a very synopsized version of what you have here. Okay, the last part, based on your analysis, do you make corrections, do another sample test? That would be yes, because you got a data set 2 here. Okay, and if you tell me no, then you got problems because you're doing another data set. Okay, so let's go back here and I'll show you how to expand these blocks out. If I just want to highlight the space in between these boxes, here, right click, insert, shift cells down, do that, then hit Control Y. You can push them down a little bit. Again, you can expand this out by raising it up, right click, format the cells, alignment, wrap, merge, border, highlight that, do that, and you have a bigger block. Same thing down here. You just do the same thing down here if you need to. But the IM chart, whoop, I'll take that back. Okay, I should have done it over here. I apologize. I was in data set 2. I didn't even realize that. Okay, so back to data set 1. Again, if I want to expand these things out, just highlight this, right click, insert, shift cells down, and just Control Y. That expands it. It just pushes this down. Okay, so you don't mess with anything else. And we're going to highlight and expand the data. Okay, it's very simple to do. It's not that hard. And then you got a bigger box to put your analyses in. You do the same thing down here if you need to. So that's data set 1. So let's go to data set 2. And basically all we're going to do is we're going to copy this formula. We're going to go over here to data set 2. And we're going to type, just going to Control V, and there whoop. Control V. Our average is going to show up. We're going to bring all the way down. Okay, and we're still going to copy the same formulas off the Word document, which I closed out, but let me get rid of this. I had to go online because I had posted this online to get the files right. So the grand mean is nothing more than the average of the averages. Again, so we're going to go back to data set 1, click there. Actually, we can click both these. Control C, go to data set 2, highlight both, Control V, and they'll just copy right on over. And then we just do the same thing. We're going to graph this and then set the axes as we have here. And then we're going to stack the data. Okay. Whoop. We're going to stack the data. And then we're going to do another descriptive statistics on the new data set. Okay. So data, analysis, descriptive. We're going to click that box. It's already highlighted for us. Just want to make sure we have all the data presented. Label, summary stats. Click OK. We have a new descriptive stats here for our new data. Control C, go back to data set 2, go up here, Control V, and we're done. Again, we're going to highlight these and we're going to format cells, number to 2, highlight all of these, and then Control Y to go to 2 decimals. Okay, then all this stuff over here, oops, shouldn't have done that. Let me undo it. So this is the same as everything over here. This should be the same. I didn't even realize that until just now. So the stack data will be copied over in this column. The spec mean we know is right here, so we can just highlight all of this so you don't have to worry about much. Okay, Control C, data set, just click right there, Control V, everything's right there. Now we're going to do the same thing we did before. We're going to highlight these, and that's going to be here. Then we're going to highlight these, and that's going to be down here. Again, you do this. Remember to format the axes specifically to the data that's being presented, and you're going to do a distinct analysis. So let's go ahead and do the charting real quick. There's our data for this. We're going to put minimum. We know how to do this already. Format axis. We're going to do fixed, fixed, fixed. Here's going to be 4.8. Actually, we're just going to get rid of all that. 4.8. This is going to be 6.2. We're still going to leave 0.2 there. Okay. Again, this now we're going to do is grab this, move it down, and now we can see that we can compare between data set 1, which is right here, and data set 2. There's a big difference. It's still erratic, but now our process mean, our natural process mean, is almost where the customer spec wants it, and both of our LCLs are well within the spec limits over here. We still have some undulation, but it's in control now. Okay, just like it is over here. It's still in control with our natural process means, but we're just not making it to customer spec. Here we are making it to customer spec, and our natural processes with our improvements that we've done have brought it well within the customer limits. Okay, so basically we're still going to be looking at some of these trends that are going on. We can do more improvements to make this more predictable, but our standard deviation has been lowered. We definitely want to make mention of the standard deviations in both our analyses for both of these data sets. Okay, that we've closed up the standard deviation to make it a tighter, more predictable process, even though we still have some erratic pattern. Okay, now we're going to do this over here to show you the difference. Okay, insert line 2D. There it is. Now you know why we have to expand to format the axes of what we want here, because we really can't tell much here. So right click, left click, format, fix, fix, fixed, minimum 4.8, maximum 6.2. And by the way, just if you ever do this and for real, as long as you're formatting your individual measures charts against the same parameters as your X bar, you're pretty good. You got it. You got the dragon slayed almost. Okay, 4.1 is the major axes. Close, and there's our data. Again, we have a lot of undulation. We have a lot of erratic patterns here. They're bouncing all over the place. Okay, but they're still in control. We want to make sure of that. We want to make sure we highlight the fact that we're in control, but we still have a lot of erratic pattern here. So we can actually, and this is reflective of the X bar. Got to make sure we say that in both analyses, that this is reflective of the X bar and it supports the X bar, because we can see the undulation here, which is driving this erratic pattern over here as a grouping. And so we can still make more improvements to get this a little tighter and to eliminate a lot of these high dips and falls, okay, or rises and falls, I should say. We can still do that to tighten up the process, okay. So that's going to be as part of your analyses. It's not going to be all of it, but it's going to be part of it. Use your own intuition and creative thinking to come up with a really good analyses. Again, we're going to do the same thing with the stack data for the spec limit. And down here we have we're going to go to 6.1, 4.9, and 0.1. 4.9, because that's just below the 5.0 requirement from the customer. 6.1, which is just above the customer spec limit, and 0.1. And there we have it. Now this is, again, this is same data here against the natural process mean, and here we're plotting it against the customer specification. So against the customer spec, we're well within the customer spec limit, okay? Even though the pattern is the same, basically you're still going to mention the same thing here. We have no out of control widgets down here. Even the pattern is erratic, but it's still well within the customer specification limits. We got to make sure we understand that. Okay, here we're plotting against the natural process limits, which are better, but the natural process limits are still exceeding the customer spec of 6.0 and 5.0. Okay, so if we can tighten this up, this will be tighter. Okay, because we're still going to be following the 6.0, these customer spec limits right here. We're still going to be following that, but if we can tighten this up, this will actually drop our process means, move this up and move this down. Okay, that's one of the things you got to remember. Okay, data set questions is basically the same as data set 1. Okay, the thing is you're not going to have the widget size specifications are going to be 0, and they're the suggestions to the problem, and that there is some problem here because there are no problem here because we're within the natural process limits. I mean the data specification limits of the customer, but our natural process limits are still exceeding those. So we want to make sure that that's annotated in the question here for the IM chart. So watch the original video and then watch this one, and you can get a good idea of the kind of analyses that you have to have in order to do well on the project. And so once you get that done, you answer all this, the project is over, and you just submit this entire spreadsheet in your in the Dropbox. Okay, and then I will grade it and I will give you back the solution and the actual analyses that I came up with to that way you can compare what you did to what I would, me being somebody who's been doing this for a long time, that's the analysis I would do. And as long as you're somewhere close to that, you're good to go. Okay, remember that this is very exact and very detailed, so you have to do that. Okay, so that ends the project video. Watch this a couple of times before you do the project. Okay, that way you follow everything step by step and you know exactly what you got to do. And remember, I'm looking for specificity. These things have got to be in these data points, and they have to have the full descriptive statistics, not just some of it. I want the full descriptive stats in here. Okay, that has to be done. The way I've just described it here in this video is exactly what I want to see when you submit your project. Okay, and that will end the project video. Thank you very much.